The universe is indeed miraculously arranged for Earth to produce and sustain life. Since the dawn of time, humanity has ceaselessly sought its own origins, collectively searching for the answer to a single question. Why are the sun, earth, and moon arranged so perfectly, allowing life to form and flourish? What is the world we live in? How does it exist and where is it located? To date, thanks to the relentless research efforts of scientists alongside the remarkable advancements in scientific technology, has gradually unveiled mysteries to answer questions that once seemed unsolvable. And the greatest, most haunting question that humanity has always grappled with is, where do we exist in this vast universe? Earth is the third planet from the Sun. At the same time, it is also the largest planet in the solar system's group of terrestrial planets. In terms of radius, mass, and density, the blue planet, it is the common home of millions of species, including humans, and to this day, that is the only known place in the universe where life exists. Our planet formed approximately 4.55 billion years ago, and life appeared on this planet's surface about 1 billion years ago. From that point on, Earth's biosphere, atmosphere, and other inorganic conditions, there has been a significant change, creating favorable conditions for microorganisms to multiply and thrive. Oxygen, as well as the process that forms the ozone layer, Earth's vital protective shield. Together with Earth's magnetic field, it blocks harmful radiation and acts as a protective shield for life. The physical characteristics of Earth, its geological history, and its orbit. Life has been able to persist to this day. Scientists estimate that Earth can only sustain life for about another 1.5 billion years, before the Sun blooms into a red giant star and annihilates all life. As of now, humanity has not yet been able to send any artificial object beyond the boundary of the solar system. Determining Earth's position within the Milky Way can, of course, only be done from Earth itself. The closest celestial body to Earth when looking out into space is the Moon. Has accompanied the Earth for billions of years. It is the largest natural satellite in the solar system when comparing its size ratio to that of its primary planet. It has a diameter of 27% and a density of 60% that of Earth. The pair are considered eternal companions. Here, we can easily determine Earth's position, and there are only two celestial bodies, the Moon and the Earth. Beyond the Moon's orbit lies interplanetary space, also known as the space between celestial bodies, including Earth. It is not entirely empty but contains a low density of particles, primarily hydrogen and helium plasma, along with electromagnetic radiation, magnetic fields, and neutrinos. The first thing we clearly see when venturing into outer space is the Sun. Most planets and celestial bodies in the solar system revolve around this star. The solar system, also known as the heliocentric system, is a planetary system with the Sun at its center and other celestial bodies orbiting around it. This system was formed from the gravitational collapse of a giant molecular cloud approximately 4.6 billion years ago. Most celestial bodies orbit the Sun, with the majority of the mass concentrated in the 8 planets. These planets have nearly circular orbits and lie almost on the same plane, known as the ecliptic plane. The 4 inner planets consist of Mercury, Venus, Earth, and Mars. They are also known as the terrestrial planets because they are composed primarily of rock and metal. The 4 outer gas giant planets have a much greater mass than the 4 inner planets. The largest planet is Jupiter, followed by Saturn, both primarily composed of helium and hydrogen. The 2 outermost planets are Uranus and Neptune. Their main components are ice, such as water, ammonia, and methane, and they are sometimes classified into a separate group called ice giants. Earth is the 3rd planet from the Sun and is also the largest of the terrestrial planets in the solar system in terms of radius, mass, and density. Going even further, it is our entire solar system, including celestial bodies from the inner region and celestial bodies from the outer region. We are passing through an interstellar cloud called the local interstellar cloud, also known as the local fluff. This is a cloud approximately 30 light-years in size, and our Sun is currently traveling inside it. Our solar system entered the local interstellar cloud approximately 44,000 to 150,000 years ago and is expected to remain within it for another 10,000 to 20,000 years. This cloud has a temperature of up to approximately 6,000 degrees Celsius, nearly matching that of the Sun's surface. It is very tenuous, with a density of only about 1/5 that of the intergalactic medium, but twice as dense as the local bubble. Local bubbles are regions of space with low matter density in the interstellar medium. The local cloud is smaller and denser, whereas Earth's atmosphere under standard conditions is more diffuse. Clouds are billowing from the Sagittarius-Scorpius association. A star association is a region with a high concentration of newly formed stars. The solar wind and the Sun's magnetic field have shielded Earth from the effects of the local interstellar cloud. Our solar system is located in a spiral arm of the Milky Way galaxy called the Orion Arm. Our Sun is located 26,000 light-years from the center of the Milky Way galaxy. Its speed around the galaxy is 250 kilometers per second, and it takes about 200 million years to complete a full rotation. The Orion Arm, also known as the Orion Spur, is a minor spiral arm of the Milky Way galaxy, approximately 3,500 light-years wide and roughly 10,000 light-years long. Our solar system and Earth are located in the Orion Arm of the Milky Way galaxy. The Orion Arm is so named because it lies near the stars of the Orion constellation. It lies between the Sagittarius Arm and the Perseus Arm, two of the four major spiral arms of the Milky Way. Within the Orion Arm, the solar system and Earth are located near the inner edge of the arm, inside the local bubble, in a position relatively close to the center of the arm and approximately 26,000 light-years from the galactic center. Passing through the local bubble, we will enter the Gondwana Belt region. As a local belt of stars within the Milky Way, it is approximately 3,000 light-years in length. But towards the galactic plane, it is approximately between 16 and 20 degrees. It contains numerous ultra-hot O and B-type stars, and it is highly likely that this is the local spiral arm to which our Sun belongs. Currently, the Sun is located about 325 light-years from the center of the Orion Arm. This belt is estimated to have formed between 30 and 50 million years ago. Upon reaching this location, pinpointing Earth's position becomes exceedingly difficult. Of course, everyone knows that Earth is a rocky planet and the third planet from the Sun. However, from this point onward, we can no longer precisely determine Earth's position, but instead, determine Earth's position based on the location of the solar system. In the next 300 years, Earth will have a second moon accompanying it. We have always believed that Earth has only one moon, but in reality, there is a moon-shaped object orbiting around us. And a recent study has revealed its formation process. According to a study published in 2016, a moon-like object is moving in orbit around Earth. Astronomers also consider Kama'olelewa to be a second moon of Earth, half-moon Bun, a Hawaiian word for a celestial body smaller than 50 meters in diameter that is in motion. It orbits the Earth in a fixed, repeating path. Bring it closer to Earth, at a distance of only 1/40th to 1/100th of the 384,000 kilometers distance from the Moon to Earth. The unusual orbit of the asteroid Kama'olelewa is the result of the competing gravitational pulls of Earth and the Sun. The constant gravitational force bends and deflects the motion of this small moon, preventing it from entering a more stable and conventional orbit. However, regardless of the perspective, Kama'olelewa continues to capture the special attention of the scientific community, as its unique composition has created a long-standing mystery that remains unsolved. Asteroids often exhibit strong reflectivity at specific infrared wavelengths. But Kama'olelewa was different. Somehow, it looks blurrier. This sign is quite clear, indicating it was made from different materials and has a distinct origin. To investigate this mystery, Ben Sake first used a telescope operated by NASA in Hawaii, commonly used to study near-Earth asteroids. But even with such a reliable device, Kama'olelewa's infrared signature was extremely faint. Instead, they switched to using another telescope with an eyepiece operated by the University of Arizona. And Sake said it's possible to extract every last gram of photons from that object. The results obtained were more promising and distinct, yet not entirely complete. This meteorite is primarily composed of silica, a common mineral also found on many other asteroids. However, they are only common in the mid-infrared spectrum, not in the far infrared region. Finally, scientists have found the answer. If Kamo-Alewa is indeed operating as a quasi-satellite, it is highly likely that it is a fragment from the actual moon. When Sake compared the data obtained from his telescope, the results obtained are entirely consistent with what geologists had previously published from the laboratory. This type of silica weathered in space while still on the lunar surface. An accurate explanation has been provided for the difference in the infrared reflectance spectrum between ordinary asteroids and Kamo-Alewa. How did Kamo-Alewa separate from its companion, the Moon? The Moon has endured billions of years of bombardment from cosmic meteorites. This resulted in nearly 500 fragments of the Moon being ejected into space in various directions. Among them, some fell to the Earth's surface and are called meteorites.